Good. So to convert to degrees or radians, just kind of a quick little formula thing here. Basically, to convert to degrees, we multiply by 180 over pi. And then just simplify. To go to radians, we do pi over 180. This just becomes like a fraction problem. So if I'm trying to do number 28, I'm multiplying by pi over 180. So I'm basically taking 27 over 180 and simplifying it. So I know I can divide them by 9, because 27 divided by 9 would be 3. And then 180 divided by 9 would be 20. And then they can't be simplified anymore. So that would just be our radians. Not the nicest angle in the world, but 27 wasn't either. I mean, it's not a number we deal with very often. Okay? Now in this section, oh, no one asked me, I thought you needed this section, Stone. 30 through 34. You got it now? So this is where you have to draw the little triangle and the reference angle has to go back to the axis. We okay? No one asked anything for 30 through 34. Okay? All right. So then 35. 35 and 36 I find to be the strangest, easiest problems. I think when I saw this on one of Mr. Hatfield's tests, I actually went over to his room and like, really, that's all you want? Because I don't remember ever teaching that. But basically a coordinate pair, what they're asking for is cosine comma sine. So all they're really asking you to do is take the cosine of 175 and tell me what that is, and the sine, because what that would be is that'd be the coordinate point on the unit circle. Like that'd be where it shows up on that circle. It's used for other things, but I kind of like, it's almost so easy, so I did cosine, and if it helps to like kind of write it out this way, it's cosine of 175, and then sine of 175. Now, I should know where that would show up in the coordinate system. I should have a good idea about that, but it's not necessary. So this is just entering this into my calculator. So like I said, kind of easiest, like tough question, because if you don't know what to do here, you're kind of lost. Like, I mean, it's, yeah.
Wasn't there problems where it was like, what are the possible...
Yeah, I wasn't going to put those on the exam, so that's why I didn't show up here. Yeah, there's things with, like, I mean, it's still possible that something could show up on the exam that's not on this review. I tried to kind of give you guys a sampling of everything, but something like that, if you ask me a question, I'll tell you if it's not going to be on the exam. So no, I did not put anything on there like that. And then 37, can I do a different one like this one? Is that okay? Just so you guys have another one to do?
Yeah.
Okay, I guess. Okay, so let me do a different one. So if I'm going to tell you, let's say I tell you that cosine of theta is, let me think of one that works out nicely. Okay, so let me tell you that cosine of theta is 7 over 25. And I'm going to tell you that sine of theta is, let's actually make it negative. And I want to find sine and sine and tangent. So this is similar to the one that's there, but I didn't want to do that one, so you guys have still one to practice like that. All right, so if they told me that cosine of theta is 7 over 25, what information are they giving me? What two sides are they giving me?
The adjacent.
Yeah, cosine is adjacent and hypotenuse. So they're giving me the A over the H. Now I do need to figure out which quadrant I'm in, because they've told me A over H. That means I have two of the sides of the triangle. I need to find the third. But I need to figure out which quadrant I'm in. So this is where we use that all students take calculus rule. So cosine, is that positive or negative? Positive. Sine is negative. So it's not all, because sine is not positive. So then we have to go into this quadrant because that's where cosine is positive. So I'm going to draw this. And when you draw that reference triangle, we always draw it back to the x-axis. I heard you guys talking about that yesterday. So it always looks like that weird kind of bow tie thing. So there's a little right triangle here. Now if they give me the adjacent over the hypotenuse, they're giving me 7 over 25. That means I need to find the opposite side. So I have to do Pythagorean theorem to do that. So I'm trying to find this side here. This is my opposite. And you'll find out that this happens to be a nice triangle, I believe.
Yeah.
It's 24, right? What kind of 24 will it be though? It's going to be negative because we're going down. So that then allows me to find the sine and tangent because sine is over h and tangent is over a. So negative 24 over 25 and then 7 over negative 24. So those are my other two ratios there. Is that okay?
Yeah.
All right. So I do, like I said, I have another review for you guys, similar link to this one. It's like basically other sections that we have not yet reviewed. Since you're not getting as big of a chunk of time to work on it, I'd be okay with saying like part of it is due for Monday. But then it needs to be done by Tuesday then. I'm assuming this is going to be it on reviews. I kind of left it up as I have part 1 and part 2. I didn't plan on having a part 3 unless I noticed something I missed, just in the grand scheme of me getting the test together and finding out that I forgot to review something with you guys. I think we'll be okay though. This does have the dreaded chapter 1 on it, but you're going to notice the chapter 1 stuff is just the front side, and the rest of it is the other stuff. So I would say the chapter 1 is maybe like an eighth of the test if you want to think about the number of points. So, and what's on here is similar to what's going to be on the exam. So this is 35 problems. I don't know. I would say try to get as much of it done as you guys can, and maybe bring questions on Monday. Monday's the last time we're like physically like have to be together before the exam, other than if you want to come for the study session. So let me get this out to you guys. I'm going to put announcements up. You guys had good questions. Let me know if there's others. If you still want another example of something, I'd be glad to do that.